Hi folks, so in this video what we're going to do is we're going to complete two questions here based on the parabola. Okay, one little mini question here drawing a parabola at an angle, and then we're going to get into a larger question down here. So in the smaller question, I'm just going to adjust my camera here so I'm looking straight in at it. And what we're going to do is we have to draw a parabola. So it says here, the graphic below shows a typical satellite dish which is the shape of a parabola. Draw the outline of the parabola in the rectangle ABCD. The vertex of the parabola should be positioned at point V. Okay, so what we're going to do is we're going to draw a parabola inside of this rectangle. Now, anytime we're doing a parabola, what we have to do is we have to divide the line here from BC, and we're going to divide that up into three portions based on the size of this one. So I'm going to do a line out from B there like this, and I'm going to do three equal measurements of 10. So I'm going to go 10, 20, and 30. At the last one, I'm going to join that to C. And what I'm going to do now is I'm going to do sliding set squares. And by dividing the line using the division of line method, okay, by doing three equal portions of 10 here, this line from B to C is now divided up equally. Okay, so we divide the line from B to C. Now we're going to divide the line from V to C, this portion of it here. So from V, I'm going to do a line off at a random angle. Once again, I'm going to do three equal measurements of 10. You could do 3 20s this time actually. I'll do 3 20s. So 20, 40, and 60. If you divide this into 3, we also have to divide this into 3. Now I'm going to connect the last point to C. And once again, use a little bit of sliding set squares to help me. And what I'm going to do now, when I've that done, that is that line there divided into 3. Now, I'm going to use my 45 degree set square. I'll just zoom out here so you can see. You can see that the line there, the line from D to C, is parallel. It's at 45 degrees. So all I'm going to do is, from these points here, parallel to the axis of the parabola, I'll just zoom in here so you can see it a bit better now. Parallel to the axis of the parabola, these guys are going to go this direction. And then from the ones at the side here, this point and this point, they are both going to connect to the vertex. Okay, and what that should help us do is find points on the parabolic curve. Now V is already a point, as is B. Okay, I have to find another 2 points inside here to be able to draw in half my parabola. So the first one is, if you follow this line here to the top. So from V, usually it follows a pattern. From V, if we go back 1, down 1. And from here, back 1, down 1. And it's essentially where the second point back from C cuts through the second line away from V. Okay, and there we have it. We have our points to draw on our parabolic curve. So from V, draw it in like that. And there is our parabolic curve. Okay, now at this point, you would come along then, and you would heavy that in. And there we go. So that is half our parabola. Now we can use axial symmetry to figure out the rest of it. So from the point here that we found, we can do a line down at 45 degrees, and from the point here that we found, a line down at 45 degrees. Using the axis then, from here to there, mark it out. And likewise, this one, adjusting my compass, from there to there. And there is my points. And all I'm going to do now is sketch in that as neatly as I possibly can. That there is our first question complete. So I'll just get this done nice and quick. You want to make the curve flow as smooth as possible. There will be marks as always on any test for presentation. Just going through the points. Neat and tidy. And now what we're going to do is maybe that line in. And there we go. That's the side view of the satellite dish there. Okay, so that's the first question done. What we're going to do now is going to zoom out here, adjust the page until we're looking straight at this one. So I'll zoom in a little bit. So the question here says, for the second question, the graphic below shows a software company logo which is in the shape of two parabolas, ABC, which we can see here, A to B to C, and ADC, A to D to C. Okay. A drawing of the logo is supplied. The curve ABC is a parabola with a vertex at B, and the curve ADC is a parabola with the vertex at D. Draw the given design. The axis of the parabola is given. So you can see we're given the axis and we're given the position of D to start off with. Now you'll see here we have to draw it inside of a rectangle. Now this line here, the axis line that is already given to us, is actually provided at an angle of 60 degrees. You'll see here, 60 degrees like that. Now what we're going to do is 60 plus what makes 90, because we're going to have to draw a rectangle here. So 60 plus 30. So we're going to go at 30 degrees here through D. I'm going to do a line like that, left and right. Now if we look at this, from D, the overall length is 160. Therefore I'm going to go 80 to the left and 80 to the right. So 80 millimeters to the left and 80 millimeters to the right. Make a little mark. And from those two marks that I just did, I'm going to use my 60 degree set square. Let's do a line down and a line down. And there we go. And the overall length then is 160. So 16 centimeters down from D. Make a little mark there. And then I'm going to go at 30 degrees like this. And that then is our rectangle that everything fits inside. So now I'm going to do a little bit of labeling. So I've got A down here, and I've got D, and I've got C over here. Okay, we'll get B in a minute. So now what I'm going to do is I'm going to divide this up, okay, like we did previously with the last question. I'm divide up the side from here, okay, going upwards, okay, and I'm also going to divide up the side from here going into D. Now D is like our vertex. So because it's quite a large parabola, I'm going to actually divide it into 5 sections. So from A, I'm going to do a line up, and I'm going to do 5 20s actually. We'll go in 20 millimeter increments. So from here, I'm going to go back 20, 40, 60, 80, 100. So you can see my little increments there. I'm going to join the last one to the end of the line that I want to divide up. And what I'm going to do now is using sliding set squares, I'm going to join it across. There to there. And we continue on in this little pattern. Okay, so I've divided the line, this edge up here, into 5 little sections. Just going to put little marks there so we can see the points. Okay, now I have to divide up the top line into 5 as well. So I'm going to do the same thing from D. I'm going to go up like this. However, this time, I'll just adjust it here slightly so you can see it a bit better up there. This time, I'm just going to do 5 10s. So 10, 20, 30, 40, 50. So from here, 10, 20, 30. You need to be accurate with your measurements here now. 50. At the last one, connect it to the end of the line you're trying to divide up, which is this line here. And now, a bit of sliding set squares, same principle. Okay, and likewise at the top then, I'm going to just put little marks on those, just so I can identify them. Okay, now what we need to do is, like we did over here where we're going to go parallel to our axis, from these points up here, 1, 2, 3, 4, 5 actual sections, but kind of 4 points to make them, we're going to go down parallel to our axis. And what's helpful here is, our axis is at 60 degrees. So using our t-square, all I'm going to do is, from all of these points, I'm going to go down, and down, down, and we continue on in that sequence. Done. Okay, now I'm going to number these, so I am, just for demonstration purposes. So in regards to numbering, okay, take this from D, I'm going to go 1, 2, 3, 4. So I'm going to go 1, 2, 3, and 4. And from this point here, I'm going to count that. Let's say this is 5, that's fine. That actually wouldn't be 5, apologies. I'm going to go with, actually I'll just call it A, B, C. I'm going to call it point X, and I'll call this point here point Y, just for the labeling purposes. Now from here then, I'm going to do the same thing. I'm going to go downwards, 1, 2, 3, and 4. Okay, now what we're going to do is, all the points on this side, okay, on the edge going from A to X, Okay, all those points there, 1 to 4, I'm going to connect them to D, which is our vertex. So 1 connects to D, 2, 3, and 4. Now, how do I find points in my parabolic curve? Well, where the one line goes through to the vertex and connects to D, where it cuts through the one line going down, that's a point. Likewise with 2. Okay, and as I said previously, follow a pattern. Back 1, down 1, back 1, down 1, and so on. Okay, the third one cuts there, and the fourth one cuts there. And now what I do, we have a point here as well at A, going to sketch in as best I can. This is quite a large one now. So trying to make it flow as smooth as possible. There we go, and I'll try and do it in one continuous path. Okay, so there we have it. Now, what am I going to do to get on the opposite side? A bit of axial symmetry. Okay, so going parallel to this line here, which is at 30 degrees, line down, and do it always from the points that we just found, and then here. And using your compass then, put your compass on the axis out to the point, mark it out the opposite side, compass on the axis out to the point, mark it out, axis out to the point, and finally axis out to the point, mark it. So there's all our points. Once again, just going to put them in my marker, and we'll sketch it in. So nice and smooth. And when you have it then, try and draw it in one continuous path. Okay, so there we have the large parabola done. Now what we have to do is we have to repeat the process here, only for the smaller one going from A to B to C. And we can see that B is at a height of 80. So from down here, I'm going to measure up 80 millimeters. So from here, up 80. And what I'm going to do is I'm going to do a line like this. And there we go. Now what's helpful about this one is, okay, I've located where B is. Just make sure I have the 80 again. Yep, it's right there. So there's B. Now I've found B, and it's going from A to B to C. Now what's helpful about this is, I have the line already divided up here. You can actually see it there. There's 1, 2, 3, 4, 5. So I've got my 5 sections here. So now what I need to do is I need to divide this line here, you can see that line there, into 5 as well. Now what I could do to save me, because I've quite a bit of work already done over here, I'm going to do it on this half over here. So what we could do is you could take the distance from the axis to one of your divisions, that distance right there, the distance from there to there, and I could mark it out this way 5 times. 1, you have to be accurate, 2, 3, 4, and 5. And now what I'm going to do is I'm going to do my line going like this upwards. Okay, so we've done it on the right, excuse me, so we've done it now on the right hand side. So now what we're going to do is we're going to divide this line here from this point here up to here into 5, because that is the height of our rectangle this time. Okay, so from C, going to do a line out at a random angle, going to measure 5 increments of 10. So 10, 20, 30, 40, and 50. At the last one, connect it to the end. Okay, and then a little bit of sliding set squares. Same principle. Going up like this. Now, if you want to do the number sequence again, well, here's 1, 2, 3, and 4, and then look going downwards, 1, 2, 3, and 4. Okay, so what do? B is our vertex this time, so from 1, connect to B, from 2 to B, 3 to B, and 4 to B. Now how do I find it? Well, where the 1 passes through the 1, where the 2 passes through the 2, 3 passes through the 3, 4 through the 4. Okay? Once again, let's sketch it in. So from B, once we have half of it, it's quite easy to get the other side by axial symmetry, but I'm just going to sketch this in first. So trying to just make it follow a path. Okay, now now that I have it done on that side, I'm going to repeat the process by axial symmetry, finding the points. So here was my point, up like this. Here is the second one, the third one, and the fourth. How do I do it? Same method. Put your compass on the axis, mark out as far as the point. There's our point there. On to the second one. Okay, and actually what's quite helpful here, I didn't realise we don't even need to use our compass because it'll be the same distance out. Yeah. So it's actually going to be here. The third one is going to be here. And the fourth one is actually going to be right there. Okay, they're actually hitting on the same lines because they were the same distances. So now, sketch it in. That's our problem complete. So that one there now can get tricky because there's quite a lot going on there and it can get confusing. So there we have it. There is our logo. Now, just to, we should have done this at the start. It's like we have two rectangles. It's like we have, let's take it as the large one. I'll put it on the outside here. It's like we have a large rectangle here on the outside, which I'll put in red. Okay, which contained our parabola ADC. Try to get this done accurately. So you can see the red rectangle here. So that's the one that contains the parabola ADC. And essentially then, the smaller parabola, which I'm going to put in blue, was this one. And this is kind of the one on the inside. So we're going from there to there, there to there. Okay, so you can see the red one contained the large parabola and the blue one contained the small parabola. Okay, so that is doing a parabola using the rectangle method, guys. Hope you found it helpful. That's the video done.